really excited for you to join our interactive science program. I'm Miss Debra.
I'm Miss Sarah.
And we're going to be showing you guys some really fun science. I wanted to remind you that the ingredients we got, like 99% of them came from Dollar Tree. So if you guys are wanting some cheaper at-home things to do, some of these you can do with supplies you may already have at home, or you may get them for very reasonable prices. So we're going to start out with one that'll take a couple minutes to kind of come together. This one is going to be invisible soda. So you use Coca-Cola and milk. And so she's going to pour in 2 parts of Coca-Cola to 1 part of milk. Oh, is it going to overflow? Are we going to have a volcano right now? Oh, not this time. All right, so let's see what happens. Dun, dun, dun. So remember that with your Coca-Cola, the carbon dioxide makes it fizz up a little bit. And so wait till it settles a little, just like she did, and then you can add your milk. And then we'll do the fun part. Dun, dun, dun. Perfect.
Didn't spill too much.
So I will do the horrible, probably messy part of shaking it up. So these test tubes also came from Dollar Tree. And so make sure it's on tight. Ooh, give it a little shake. And if it explodes a little bit, make sure you have it on a plate like we do. And then we're going to just leave it be for a couple of minutes. And always make sure you've got napkins handy when you're doing science.
Science is messy.
Science is very messy. So while we're waiting on that one, we're going to do another one that's going to be a little extra messy. Thank you. And that is going to make a little tiny explosion. It's called citrus suds.
Explosions. I love explosions.
We love explosions. So we have dish soap already in our little test tube. You want to have like an equal part of dish soap, and you add in an equal part of baking soda. That's the first step. And then at the very end, go back to that. At the very end, we will add citrus. So in our case, that would be like we used lemon juice in the little like lemon container, but you could also use a real lemon and juice it into there.
All right, Debra, are you ready for me to?
I'm ready. What's gonna happen? What's gonna happen? Ooh.
Okay, so it's in. As you can see, we'll go a little bit closer. It's just starting to sink a little bit.
Ooh. So shake it up a little bit, and then we'll add that. Ooh. See it? Starting to mix up gooey, gooey good. All right, you think it's about ready? We'll see. And it's gonna get a little bit, you want me to hold it while you squirt?
Yes.
Do you wanna see it get messy for a second, guys? Hopefully it'll work.
Oh.
Do you hear it? I don't know if you guys, maybe we should do more. Oh yeah.
Bubbling, running over.
So that's a different way that you could do a volcano than maybe you traditionally have seen done. And a lot of people clean with baking soda, and most people use dish detergent unless you use solely your dishwasher. So this one you could do very easily. Oh, it's exploding! Love it. And now our plate will be clean. So let's talk about the science behind that one. So when the citric acid, so that's the lemon juice, combines with the baking soda, a chemical reaction takes place, producing carbon dioxide gas, that's the bubbles, and water, and you get a bit of sodium citrate, just in case you were wondering. All right, next up, we're gonna have to have a race. So, will you grab the water, Miss Sarah? If you put the water on the table, we can have them see it like this. You guys love change. You probably have a piggy bank at home. And one thing you can test is how many drops it takes before your water on your penny overflows. So we're gonna use a pipette. At home, you could use a straw. With your straw, you would hold the end of the straw, open it in the water, close it to hold the water, and then let go for each drop. For us, it's the opposite. You close it, drop it in the water, let go, and it fills up. So you could experiment with that with a straw if you don't have a pipette at home, although these were like $3 for 12 on Amazon. And so Miss Sarah and I are gonna see how many drops it takes to make your penny almost overflow. Ready?
Okay,
1, 2, 3, 4, 5, 6, 7. Ah! What was yours?
Mine was 5, I think.
Hers was 5, mine was 7. Now, admittedly, our drops may not have been the same size, but one thing you can see more closely, hopefully, is that a bubble forms on top of the penny of water.
Look at that dome.
Can you see the dome? So let's talk about the science of our beautiful dome. So there are 2 properties that are at work in this experiment: cohesion and surface tension. Cohesion is the attraction of like molecules to one another. So in this case, the molecules that are alike are H2O molecules in the water drops. Surface tension is a special term we use to describe the cohesion between water molecules. You've probably seen surface tension if you go outside and you see like a spider and it looks like the spider's walking on the water.
Yes.
Yeah. Water's cohesion and surface tension are special because of hydrogen bonds. Hydrogen bonds are formed by the hydrogen atoms of one molecule being attracted to the oxygen atoms of another molecule. The cohesion and surface tension of water is apparent when the drops of water reach the penny's edge. You could see that dome forming, especially when we zoomed in really close on the penny. That bubble shape is because the water molecules cling to one another in what they consider an optimal shape. Just like when you blow a bubble, it makes a round circle, right? So some of the science will be easier and some will be harder. We hope that some of you younger kids are watching, and maybe some of you adults by yourselves. All right, so how's this one doing over here? Is it starting to separate out? Oh, a little bit. You can
Looks
see the
like-
foam on top.
Looks like chocolate milk.
Do you think we should try the chocolate milk?
Yes.
Yum.
No.
No. Well, maybe.
No.
So let's do another one that might take a little bit of time. We're gonna do the Skittles experiment. Who likes Skittles? Me, 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 me. Do you have a favorite color Skittle? My very favorite one is purple. Do you have a favorite, Miss Sarah?
I like the red.
Red? I bet my nephew likes the green because that's his favorite color. So she's laying out the Skittles in whatever pattern, and we're gonna pour water on them and see what happens. Ooh.
Purple.
Once
so
you
we
get
can
it
see.
laid out, I'm gonna carry it for you to the camera. Can you grab the water for me, please?
Yes.
Okay. Ooh, she has a cool pattern. Let's see what happens. So just pour the water so that it makes a thin layer. That's perfect. Along the bottom.
Oh, I can see it happening already.
Ooh, so you guys, we're gonna let this sit on the table, and then we'll bring the camera to it toward the very end so that it's very still. So that will be our Skittles experiment. Are you guys ready for another one that's a little bit messy? Yeah, I think
Yes.
it's time for that. So this is gonna be exploding colors. So we have some beautiful milk in a water bottle. You could use like just a cup, that's just what we happen to have, and a turkey baster. And Miss Sarah is going to put maybe half of the turkey baster full of milk. She's gonna guess, but you wanna fill up the bottom of your plate. Ooh, fancy. Maybe a whole one. So however many times, this isn't an exact measure, you just want a full layer on the bottom of your plate.
All right. We got it over here.
Ooh. And then, this is the fun part. Which ones do you want, Miss Sarah? We have our food coloring, red, yellow, green, and blue. Which two?
I'll do green and blue.
So they say to do one of each color, but we're gonna mix it up and just put however many we want. Because part of science is fun, it's just doing what we wanna do.
And make lots of mess.
Absolutely. Oops.
That yellow top looks orange.
So I'm gonna carry this plate over so that you guys can see it. And Miss Sarah's gonna bring the Dawn dish detergent and a pipette. And she is going to help it to explode.
All right.
So it says to do one, but are we go? Oh! Can you guys see that? Maybe do another one. Will it still do? Ooh, very beautiful.
It's like they're exploding and expanding.
Yeah.
It's like the universe.
It is like the universe. That's a beautiful analogy. So, let's talk about this. Oh, and our Skittles are looking really great. We're gonna have to bring the camera over to that one. So this one is another big science one. So milk is mostly water, but it has vitamins, minerals, and proteins. And tiny droplets of fat are suspended in the solution. So we got whole milk. The higher fat content of milk, the better this will work for you. Fats and proteins are sensitive to changes in the surrounding solution, so the milk. The secret of why it bursts colors is the chemistry in that tiny drop of dish soap. Like other oils, milk fat is a non-polar molecule, so it doesn't dissolve in water. When soap is mixed in, the non-polar portion of the molecules break up and collect the fat particles. When the polar surface of it's called a micelle, connects to a polar water molecule, the fat is held inside the soap. Thanks to the soap, the non-polar fat is carried by the water, and that's when you start seeing it rolling. The fat starts to roll, twist, and contort in all directions. So, during all of this molecule gymnastics, the food coloring is bumped and shoved everywhere, and it's making it very easy for you to see all the things that are usually happening but are invisible to your eye. And you see an explosion of color. Yeah.
Nice.
So let's see how this one's working out.
Still looks like chocolate milk.
Still looks like chocolate milk. Maybe this one will be a fail. We'll have to see. Here's one that's a little bit tricky. Do you want to try the tricky one with me?
Oh, yes.
Ooh, okay. I'm gonna pour a whole test tube full of water. And I've seen people doing this one on like social media with a big cup. I'm still too nervous, and we're definitely gonna have to do it over one of these plates.
That is showing the dome effect again.
It is showing the dome effect. I didn't see that, Miss Sarah. Very cool. And then I'm gonna pour my own, and you have to pour it all the way to the top until you see that little dome. And if you overflow, it's okay.
Especially when you have a plate.
Especially if you have a plate, that is correct. Then you take your card, and you can feel it sort of suction onto that bubble, and you hold it with your fingers, flip it upside down, and if it works, you'll feel it slightly like, oh! Do you guys see it? Let's see if I can make it to the camera. Ooh, ooh. But if you move the card, it all falls out.
That was so.
Let's do an extreme close-up on our Skittles, and then we'll talk about both of the sciences of those. See 'em? So, first let's talk a little bit about our magic trick that we just did. Make sure you practice very well. And something I found out pretty quickly is if you let go of your fingers before you flip it, water will go everywhere. So that was the hovering water trick. So all of the molecules in the atmosphere put pressure on everything. Scientists already know that sea level air molecules in the atmosphere put 15 pounds of pressure on us per square inch of surface area, but you don't even notice it. When you first turn the cup, or in our instance, the test tube upside down, the pressure inside and outside are equal. If you look closely, and that's I think when you feel the little pull, you'll notice that a few droplets separate out when you like turn it upside down. This happens because the force of gravity pulls down on the water. So when some of the water escapes, the volume of air increases. So even though the amount of air above the water stays the same, the volume occupied by the air is now greater, and the air pressure inside the cup and card stays in place. All of this is possible because water makes an airtight seal on the rim of the cup or test tube and the card. So let's get back to our friend, the Skittle experiment. You guys kind of could see when we did our extreme close-up a little bit of what that looks like. Did the colors spread, Miss Sarah?
They did.
Want to do one more little close-up?
Yeah.
Ooh. Very neat. So why did they do that? This one's really fun. Skittles, when we think about healthy food, Skittles are not the top, but treats are great sometimes anyway. So Skittles are coated in food coloring and sugar, which is probably why I like them so much. When you pour water over the Skittles, the colored coating dissolves and spreads through the water. The color and sugar dissolve into the water and then diffuse through it, making the color of the Skittle. Why did the Skittle colors not mix? Could you see that they kind of kept in their own zone?
Right. Yeah, it was like they were square.
Yeah. And if you just do two, it'll divide down the middle. So it's a neat thing to try different numbers of Skittles and different patterns of Skittles because it always will work about the same. You could also do hot water. The reason that the food colors meet in the middle of the plate as a cross and do not mix is because each food color has the same amount of sugar dissolved from each Skittle. As the sugar is dissolved, it is pushed outwards into the rest of the solution, sending the colored water outwards as well. That's pretty cool.
Yes.
So our one that was a little bit questionable, I have to admit, is the Coke and milk. And so with science, sometimes you try it and it works, sometimes you try it and it doesn't. So we're not gonna stress about it, but if you guys wanna try it at home, and I might even do a time release video for you guys, if you put milk, I'll put it in this big Coke bottle, and I'll put it in the comments so you guys can see what it looks like when you do it on a bigger scale. And I'll tell you the science of it just so that you have it for later. When you dilute Coke with milk, the acid, the phosphoric acid in the soda curdles the milk. Do you want to drink curdled milk? No? Me either. Into little globs. Ugh. The surprising chemical change occurs throughout the bottle, and it's followed by a physical change as the curdled milk slowly falls to the bottom. The chemical change is phosphoric acid in the soda pop reacting with calcium in the milk to make two new products, tricalcium phosphate and hydrogen. Tricalcium phosphate is the precipitate that falls out of the liquid and settles on the bottom, taking almost all of the caramel coloring in the soda with it. And then hydrogen gas bubbles all the way up to the top and fill the space under the cap. So it ends up being different colors. So you guys could try it at home, and sometime today I'll try it out for you, and when we release this video, I'll definitely add it to the comments. Are you guys excited about trying some home science?
This was a lot of fun.
Yes, thank you, Miss Sarah. Good job. Let's give Miss Sarah a hand. Let's give me a hand.
Debra.
You guys make sure and be doing all kinds of science and thinking about the way the world goes. If you guys are interested in more science programs, let us know in the comments. Thank you.
Bye.
Bye.